So, all right. So now that I have all the data in, what I want to do is I want to actually split this up because I want two separate methods here, and I'm going to put them both on the database. So these are going to be static methods on the database. And the first one is going to zero out all the data and then add the starter data. So it's going to rebuild the database essentially with the right data in it. And then I'm only going to call that when I basically am doing development and I need to zero out the database and restart it so that I can test stuff out. So for development purposes, I'm going to have something that zeroes out the data and restarts it. And then I'm going to have a method that reads all the data when the program starts up. So let me talk about design here for a second too. So my strategy for using the database here, it's going to depend on how I'm actually using the program. So let me give you two different alternatives. So the first alternative is like really tight coupling between the program and the database. So basically every time anybody makes any kind of change, that will immediately get written out to the database. And every time somebody accesses an object like an instructor or an instructor list, it's going to refetch that from the database. Okay, so it will be heavily coupled. Any change that I have in memory is going to be reflected in the database instantly, and any change in the database is going to get reflected in my in-memory data instantly as well, or every time I go to look at it anyhow. So that's version 1 of the program, or version A, and then version B of the program is going to be as follows. So when I start the program up, I'm going to read in all the data that's in the database, and I'm going to keep it locally in the running program. And then I'm not going to read it from the database anymore. But anytime the user makes a change to any of the data, like creates a new instructor or updates some information about instructor, makes a new instructor list, and so on. Anytime I do any of those things that changes memory, I'm going to make those changes to the database. Okay, so it's going to be write only, basically. When I start the program up, I read everything in, and then it's write only past that point. So that's version B. And then version C of the program, because I guess there's 3 possibilities, is I read everything in when I start the program up, and then I make whatever changes in memory that I need to make when I'm running the program. And then when I exit the program, everything gets written back to the database. Okay, so in the first version, every time I do anything, basically, almost anything, it's going to either read from the database or write to the database. In version 2 of the program, I'm only going to read once when the program starts up, but when the user makes changes, I'm going to flush those back immediately to the database. And in version 3, I'm not going to read or write, except for once at the beginning, I'm going to read everything, and once at the end, I'm going to write everything. It's obvious why I might want to do, well, fetch everything in the beginning and then not fetch it again, just for efficiency, because going to the database is a slow operation. So the question was, why would I want to go back to the database even after I had read everything? If you're in an environment where it's multi-user and different people are accessing the same information and some of them are changing it, then you might need to get those changes right away. So depending on the type of application, I might need the most up-to-date information available. And the only way I'm going to get that is to go back to the database every time the user accesses the information. Okay, so thinking about your password manager program, is this your account information Is this a multi-user system where other users are going to be accessing the same information you're accessing and updating it? The information you are looking at should only be visible to you. Nobody else should have access to your account information. They would have access to their own account information, but they shouldn't have access to yours. They shouldn't be able to read it or write it. So the only sort of weird exceptional cases here are like ones that involve you personally using multiple machines, where you basically are running the same password manager on multiple machines and moving back and forth from one to the other. And you make some changes in one, but you don't cause them to be flushed. You make the changes to the other, but you don't cause them to be flushed. And so you're not going to see those changes. You don't exit the program and restart it each time. You just have it running on all of these machines and you access them. So if you only read the data when the program starts up and you only start the program up once and then you don't restart it, but then you move around from machine to machine and you make updates, it's possible that you would make some changes on one machine that were not immediately visible on another machine until you stop one program and started it up again. If you wanted to prevent that, you could make the program significantly less efficient by doing what I described for the first version of the program, where every time you make a change to something in memory or access something in memory, you either write it to the database or fetch it from the database. That's the least efficient version of the program, but it's also the one that's going to guarantee the most consistency. And it's what you would have to do if you were supporting a multi-user concurrent system where lots of people were making changes at the same time. So there's a penalty for supporting that kind of access pattern in your program. On the other hand, for this kind of program, for the program that you're working with, where only one person really is going to be looking at any particular set of data, the access pattern there, for the most part, indicates that you'd be pretty safe reading it once and then not reading it again until the program exits and you start the program up again. There are some potential gotcha there's. Once again, if you're accessing the same information on multiple machines, you may have an inconsistent situation, but we're willing to put up with that because you know what you did. You know you made a change on machine A and not on machine B, and you know whether you saved it or not. And so the behavior of the program is understandable to you. So I think that's reasonable. Now, on the other side, though, why would you want to flush the data anytime it was changed as opposed to waiting till the end and flushing everything all at once? Well, programs crash, and sometimes people don't exit the system. And if you make it so that the changes only get flushed when somebody exits and they, the machine might crash. And so the changes never get flushed, which is annoying. Or B, I might not exit the program. I might not flush the changes. And so if I start the program up on a different machine, I might not have access to the changes I made. So that's kind of irritating. And it definitely affects a one-person system where only one person has access to the data. So, you're on your home theater computer and you're running the program and you access an account and you change the account information there, but you don't, you don't shut the program down to flush the changes. And then you go to your other computer and you can't log in because you don't have access to the account change information that you made. That's annoying. And it's annoying enough to me personally that as a design decision, I think it's good to flush any changes I make right away so that I don't risk losing them if the program crashes and so that they're available when I move to a different machine and start the program up again. So I'm willing to, in the sake of efficiency, only read once when the program starts up, but I'm not willing to only write once when the program exits. And so that's the design pattern that I'm going to use here for this version of the application. But I could go any way depending on what I think the access patterns are going to be like.